Algebra 1, Exponential Growth and Decay. So we're going to continue working with exponents, but we're going to do something really different now. We're going to look at exponents in real life situations. The first situation would be in a situation of exponential growth. So to get down a definition, this is when an amount increases by a certain proportional rate. So it's increasing twice as much each time, or by 33% each day, or by 17% each year. Exponential decay is when an amount decreases by a certain proportion. Now the other thing to get down is the formulas that I have there for you. So we can take real life situations and rewrite them in math equations by using our formulas. So for exponential growth, our formula is y equals a times 1 plus r to the t power. And then for exponential decay, y equals a times 1 minus r raised to the t power. Make sure you insert those parentheses where I have them, just like you see the formula there. And remember, pause the video if you need to get down the definitions and the formulas. The last part of the formula, though, is to explain what each of those means. So in a real life situation, you always have a starting or an initial value, and that is what A stands for in our formulas. So that is what we call the initial amount, starting amount. R is the rate that your situation is increasing or decreasing by. And then T is the time period over which it increases or decreases. Now when we talk about exponential growth or decay, there's always a growth or a decay rate. And so this is either the decimal or the percent portion that the original or the initial amount increases, grows, or decreases, decays. Now before we jump into some situations of growth and decay, we need to talk about rates, because these rates will show up in your real life situations as percents. But when we work with percents in our math equation, we need to change them into hundreds, because remember, a percent is a comparison out of 100. So to do that, you're going to move the decimal place 2 to the left. So move it 2 to the left. And the reason is because it's tenths, hundredths, 2 decimal places. So 50% has a decimal here, but as a number we need to write that. So we'll go 2 places to the left as 0.5. So 25%, right now the decimal's at the 5, so if we move it 2 to the left, that is the same as 25 hundredths. Because remember, percent is a comparison out of 100. This is 50 100ths. Now a number like this, 3.3, we have to move it 2 places, and you're going to need to add a 0. So the decimal equivalent is 0.033. And for 85, we move it 2 places, so it'll be 0.85. So when you're working a real life situation problem and it gives you a percent, when you go to put that into your formula, you're going to first rewrite it as a decimal. The next thing I'd like you to do before we jump into real life situations is just to look at equations and figure out if they're situations of growth or decay. So I want you to think about the exponential growth and decay formulas or functions to help you. So I've put them for you on the video, and you can also look at them in your notes. So in number 1, y equals 3 times 1 plus 0.8 raised to the x. Now you don't have it quite in the form 1 plus, but if this number is greater than 1, that means that 1 has been added on to the rate, and so it is a situation of growth. So look at number 2. 10 times 0.3. So see how that number is less than 1. So that means that some rate has been subtracted from 1. So this is less than. So that's a situation of decay. And then finally, look at your multiplier here. It is greater than 1, so this is a situation of growth. Now we'll do the real life situation. So we're going to read each situation, decide whether it's growth or decay, and then pick the formula that we need to use and set up a situation to model. So this year, a neighborhood association charges $150 per year for its homeowners association fee. Every year, the fee increases by 3%. What will the fee be after 5 years? So since it's increasing, that's the word you want to look for. That means we have a situation of growth. The initial amount is the starting amount in the situation. So that's our $150. Our rate is going to be that percent proportion that we're told. Now we're going to go ahead and change that to a decimal. So here's the decimal. We go 1, 2 places. We need to add that 0 in, so it'll be 0.03. And then our time is 5 years. So since it's growth, we're going to use our growth formula. So y equals a times 1 plus the rate, all raised to the t. So our beginning amount is 150. 1 always stays the same. And what the 1 does is that brings the original amount into our equation. And then our rate, we're going to use decimal and raise it to the 5th power. Now let's do parentheses first. Now grab your calculator. So think of order of operations. So take 1.03 and raise it to the 5th power first. Then take it times 150. This is a money answer. So we're going to, since we weren't told differently, we're just going to round to cents. So that means 2 decimal places. So $173.89. All right, number 5. 1,000 people visited an online auction site during its first month in existence. The number of visitors is increasing by 300%, or it's tripling each month. How many visitors will the auction site have after 9 months? So, growth or decay, I'm sure you're saying it in your head right now. The language increasing. So we have a growth situation. So now you want to look for your initial or beginning amount. That's 1,000. So rate is going to be that percent number, but we need to change it into a decimal. So we'll move it 1, 2 places. So it's actually going to be 3. And then our time. So notice it says it's increasing by month, and then how much after 9 months. So our time is 9. So we'll use our growth. Let's just rewrite that formula so you can learn it. And then we'll start with 1,000 times 1 plus 3, all raised to the 9th power. Now do what's in your parentheses first. Then take that 4 and raise it to the 9th power. After that, multiply by 1,000, and you've got lots of people visiting that site. So 262,144,000 visitors. Nadia received $200 for her 10th birthday. If she saves it in a bank account with a 7.5% interest rate, compounded annually, what will the balance in her account be at her 21st birthday? Now there's some language in here you might not have heard before, but it's language that will become very common knowledge to you. Bank accounts often have a percent of money that they give you for keeping your money. And so that is called your interest rate. Interest rate is always going to be an increasing, a growth situation. So we've got a situation of growth here. Balance is the word that banks use to indicate the ending amount. So our initial amount is $200. The rate is 7.5%, but remember we're going to move that decimal, have to put in a 0, so 0.075. And then 10th birthday, and we want to know 21st birthday. So in 11 years. So since we're growing, we'll use our growth formula. So $200 plus our rate, all raised to the 11th power. Remember to do what's inside parentheses first, raise it to the 11th power, and then take it times 200. So if she just lets it sit there, it's going to more than double. She'll have $443.12. Number 7. If a person takes 125 milligrams of a drug like Tylenol, the amount of the drug in a person's bloodstream is reduced by 30% each hour. So what is the amount of drug in the bloodstream after 3 hours? So let's look for language to tell us whether it's growth or decay. We've got the word decreasing, reduced. There it is, it's reduced. So this is a situation where we are decreasing. So the initial amount is at 125 milligrams. Each hour, it's going to be 30% less. So 2 decimal places, 1, 2, so that'll be 0.3 or 0.30. And then after 3 hours. So this time we're going to use our exponential decay. So we're going to subtract that rate of decrease. So it's 125 times 1 minus 0.30. So do what's inside parentheses first. Now notice before you put on your calculator, see how you have a number that's less than 1 because we subtracted that rate from it, and this is a decay situation. So raise that to the 3rd power, take it times 125, and you should get 42.875 milligrams. So it should be considerably less because it's decreasing. Number 8, a person is infected by a certain bacterial infection. When he goes to the doctor, the population of bacteria is 2 million. The doctor prescribes an antibiotic that reduces the bacteria population to 1/4 of its size each day. Find the size of the bacteria population after 2 weeks. So it's reducing. So we have decay. Now our initial amount is 2 million. Our rate is given a little differently, so 1/4, but if you divide that out, that's 25. or 0.25 actually, 25%, 0.25. And then after 2 weeks, but it's 14 days because it says it reduces each day, so we want to put our number in terms of days. So we're going to use our decay formula. So we'll take the original amount, 2 million, times 1 minus the rate, raised to the 14th power. So remember, do what's inside parentheses first, raise it to the 14th power, take it times 2 million, and you should have 35,636 bacteria left. In our last situation, number 9, that we'll do together, then you'll do your teacher talk, find the balance in the bank account after the given period. So we got money again in bank account. $6,000 principal. That's another word that you'll see in money situations. Principal is your starting amount. So you can always know that principal is your A value. 6.5% interest, sorry, not interested, but interest compounded annually. So 6.5. But we're going to move that decimal 2 places. So we'll get 0.065 and then 4 years. So money in your bank account is going to increase, sometimes not all that quickly, but it does increase. So 1 plus 0.065 raised to the 4th power. Okay, so parentheses, then take that to the 4th power and finally times 6,000, and you should get 7,718. Now we're going to round to the nearest cent, so that's hundredths place, so that's 0.8, and then we put a 0.